Let's take a look at how measurement uncertainty plays out in a simple navigational sample. Here on the chart, we're drawing 3 bearing lines to fixed objects. Those are compass bearings taken from the ship, and they should run through the single point in space where the ship is located. In fact, they don't. They form a small triangle. Now, usually, navigators know that this is likely to happen, and they pick a location somewhere inside the triangle formed by the 3 bearing lines. Is that a reasonable thing to do? Well, let's actually plot the range of possible values each bearing could have. Now, the range varies depending on the instrument used and the method and conditions by which it was measured, but the basic idea is that any measurement will lie within a range of values, the highest and the lowest being the uncertainty, or the tolerance in engineering, or the confidence interval if you're doing statistics. So let's draw that on the chart. Let's draw a red line at the highest possible angle and a red line for the smallest possible angle from each of our fixed objects. We know that the ship lies somewhere between those 2 red lines. After we've done this for each of the 3 bearings, we'll find an area of intersection, and the ship should be somewhere in that area. Here on the screen, it's marked with a small red triangle. Notice that this small red triangle intersects significantly, but not perfectly, with the small triangle we got simply by plotting the bearing lines. Now, the question is, practically, how do we handle this? Practically speaking, if we pick a likely location inside the intersection, the cocked hat created by the 3 lines of position, that'll be good enough for any practical purpose, assuming our triangle is relatively small. However, there is a very real possibility that you are outside of that small triangle, and so the prudent navigator will keep that in mind, as well as keeping an open mind to any additional information they have about their position. Hope this helps. Check out our video on the 3 bearing fix if you'd like to see more about how to do this.